Hello everyone, I'm Nikos Antonopoulos. I'm a PhD candidate in the Department of Crop Science at the Agricultural University of Athens, and I'm going to present you some weed management methods on physical strategy. With this presentation, we are going to explore physical strategies for weed control, effective and sustainable methods that directly control weeds without relying on chemical inputs. Physical strategy focuses on preventing, removing, or suppressing weeds. It aims to disrupt weed life cycles at various stages through mechanical interventions. Physical strategy as a term often integrated into broader weed management strategies alongside cultural and biological approaches, and it is an essential component of sustainable and integrated weed management. Physical strategy for weed management includes several methods such as mechanical weed control, electrical weeding, laser weeding, mulching, thermal methods such as hot foam application and flaming, and flooding. Let's start with mechanical weed control. Mechanical weeding offers a strong alternative to synthetic herbicides by physically disrupting weed growth. This approach, often enhanced by precision agriculture technologies, provides an effective and sustainable solution. Methods include inter-row cultivation using tools like hoes, brush weeders, and split hoes, as well as intra-row weeding with finger weeders, torsion weeders, and flex-tine harrows. Mechanical weed control should be used as part of an integrated weed management approach. Farmers should select tools that are appropriate for the crop spacing and use them at early weed growth stages. Combining mechanical methods with strategies such as crop rotation can improve long-term weed suppression and the overall resilience of the system. Electrical weeding is an innovative approach to weed management in agriculture. An electrical current passed through a weed turns into heat energy within the plant, causing the cells in the roots and foliage to burst, causing death or suppressing growth. Electrical treatments offer application flexibility, and the efficacy depends on contact time between the electrode and the plant, electrical voltage, weed species morphology, and soil characteristics. Electrical control offers opportunities to reduce reliance on herbicides, lowering the risk of soil and water contamination and mitigating herbicide resistance issues. Laser weeding technology is rapidly progressing. This method offers application flexibility with no crop growth stage restrictions. Laser weeding requires the use of a machine with cameras to detect weeds between crop rows and then controls them directly by a focused laser beam in real time. This weed control solution requires high-tech equipment and offers potential to reduce herbicide usage and enhance wider environmental benefits. In addition, the lack of soil disturbance offers benefits to soil structure when compared to conventional tillage. Next, another method of physical strategy for weed management is mulching. Mulches are defined as layers of organic material such as straw, hay, wood chips, or compost, which are applied to the soil surface to suppress weed growth. They block light, inhibit germination, retain soil moisture, buffer soil temperature, and contribute to organic matter and nutrient cycling. Mulching can offer benefits to farmers by reducing reliance on external inputs, enhancing on-farm nutrient cycling, providing low input weed management, and supporting long-term soil health. Let's move on the hot foam. Hot foam applications represent a new smart concept in the area of thermal weed control and are proposed as an evolution of simple hot water or steam applications. The advantage of foam is that it isolates the weed from the ambient air at the time of treatment and transfers all the heat energy to the plant tissues instead of escaping into the atmosphere. The method also overcomes drawbacks associated with the use of synthetic herbicides, conventional thermal weed control methods, and contact bioherbicides. Hot foam is applied with foam stream machines provided by Weeding Tank Company. The solution foam stream V4 contains 100% mixture of plant oils and sugars. The tank content is 96% water and 4% foam stream V4. The emission class is Euro 5. The hot foam spreader is 30 centimeters wide and the flow rate is 12 liters per minute. The temperature of the water is 98 degrees. Weeds at early growth stages are easily controlled, while weeds in advanced growth stages should be creamed first so that the foam covers the entire leaf area for best results. Until now, most research results come from non-crop areas. Hot foam is a non-selective bioherbicide. However, in recent studies by our research team, we have found that this method effectively controls weed in the intra-row space of orchards and vineyards. Hot foam application can be also performed with the stale seedbed concept in arable and horticultural crops. The symptoms on weed tissues are visible at a very short time after treatment. Right after treatment, treated weeds smell like boiled spinach. It is very possible that hot foam application may sterilize the soil and cause weed seed mortality, reducing the weed seed bank. Another method is flame weeding. Flaming provides an eco-friendly alternative to synthetic herbicides, suitable for both small gardens and large-scale farming. It works by rapidly heating weeds, causing a thermal shock that makes their plant cell burst. This isn't actually burning. Instead, the heat vaporizes the water inside the plant tissues, leading to cell collapse. As a result, the plant can no longer move nutrients to its roots, ultimately causing it to die. The method is effective in managing newly germinated broadleaf annual weeds and young seedlings of broadleaf perennial weeds. However, established weeds often recover quickly after exposure to flame weeding. For large-scale field operations, the equipment usually involves propane tanks and burners mounted on a tractor. We would say that flame weeding can be combined with mechanical weeding to reduce herbicide application. One more weed control method of the physical strategy is flooding. Flooding primarily works by creating anaerobic conditions in the soil, which many terrestrial weed species cannot tolerate. It causes oxygen deprivation, the water fills the soil's pore spaces, pushing out oxygen. Most terrestrial plants, including many weeds, need oxygen in their root zone to survive and perform respiration. It offers also suppression of germination. Many weed seeds require oxygen and specific moisture levels to germinate. Flooding can prevent germination by creating unfavorable conditions. In addition, smaller tender weed seedlings are particularly susceptible to direct drowning. There are also some limitations and considerations such as crop tolerance, the water availability, and the soil health. Thank you for watching.